I haven't done one of these in a while, so this is interesting. I've already taken about 15 pictures of myself because I keep hitting the wrong button, so this should be exciting. Okay, guys, so Vertex form, sorry I couldn't be there at a game, as you know. I think you're going to like this lesson. So extension 8.4 is something called Vertex form, and you're going to learn this whole new way of graphing a quadratic using the vertex. So here we go. Extension 8.4, Vertex form. This looks a lot like an absolute value function. Here we go. So when something is in vertex form, you have the vertex. So you're going to have that highest or lowest point on your parabola. So your form, by the way, my book is over here, so if you see me looking this way, that's why. Your vertex form, y equals a times the quantity x minus h. Where's my square? Square plus k. Does that look familiar? Because if you swap out these parentheses with absolute value brackets and take away that square, that is a 2, looks like a 3, you have your absolute value function. Okay. Now there's a couple things on this one. A cannot equal 0, just like it cannot equal 0 in your quadratic function, just your basic y equals ax squared plus bx plus c, because if we had a that was 0, then we'd have a linear function. So a always has to be anything but 0, whether it's greater than 0 or less than 0, that part doesn't matter. So a can't be 0. Now in vertex form, h and k is your vertex. H and k is your vertex. So this is all blue, but make sure you like star this, arrow this or something so you know that your h, k is your vertex. Now, just like your absolute value form, remember you had the absolute value of a on the outside, a times the absolute value of x minus h, and then you had to take the opposite of whatever h is, because remember, we are subtracting h here. So if we're subtracting a negative, inside those parentheses right here, it's going to say x plus h. So if you just have to identify the vertex, just take the opposite of whatever this is. So if it's, right now it's negative h. So that means h is going to be positive. So just kind of keep that in mind, because this is very, very similar to your absolute value function. Now when you graph in vertex form, all you do is you identify the vertex first, and then you identify your matching values of x to find other points on the parabola. You do not have to find the negative b over 2a. That is only when your quadratic is in standard form, that y equals ax squared plus bx plus c. So let's give this a go. Here we go. Example 1. We're going to graph, as in every other problem, y equals the quantity x take away 4 squared, and we're going to compare it to the parent y equals x squared. Okay. You do not need to find the axis of symmetry. You do not need to square this. Actually, multiply it out. You do not have to do that. All you have to do is identify your vertex and go from there. So in your vertex, we have x minus 4. So here we have x minus h. So this is going to be, remember, we're going to take the opposite of negative 4. So the vertex is actually 4. And since we don't have a k, that means it's going to be 4, 0. So whatever h is, just take the opposite of that, because remember, you're subtracting a negative. It's not a negative, pardon me, you're subtracting a number. So if you're subtracting 4, you're actually subtracting a positive 4. So just take the opposite. Okay? That's your vertex. So that's your highest or lowest point. And actually, taking a look at the graph, since a is positive, that means your vertex is now, it's the minimum point, which is going to be your lowest point on your parabola. So when we graph this, we still pick points where our axis of symmetry, because remember your axis of symmetry is the x coordinate in your vertex. Put that in the middle, 1 in front, 1 behind, and then 1 more in front of 5, which is 6, and then 1 more behind 3, which is not 3, sorry, 2. So you still pick your extra values of x the same way. It's just your vertex is going to be based on your equation. And then you could choose to double up if you want, or if you want to do singles. But remember, if you double up, you have to grab points that have the same distance to that axis of symmetry. So here's your axis. 6 and 2 are both 2 away. That's why you have to double them up. So that's just a reminder. So here we go. Let's just double them up. Okay, so remember, when you guys double up, you could pick either X to put in to show your work that you're not squishing. So I have 2 and 6. When I double up and everything's positive in vertex form, I tend to pick the bigger value, but it really doesn't matter. It's honestly just a personal choice. So I'm going to plug in 6 minus 4, and we're going to square that. Please follow your order of operations. Parentheses first. So we have 2, we're going to square that. 2 squared is 4. So don't forget, you have to include both x's. So you have 2, 4, and 6, 4. And then you're going to do the same thing for 3 and 5. Jeez, I really can't hold that board up that close anymore. So taking just a kind of quick glance at looking at your function that they give you, I'm going to pick bigger values than 4 because I don't want to deal with negatives. Whatever you want to do doesn't matter. So subtract that, we get 1. We're going to square that, and we get 1. So over here we have 3, 1 and 5, 1. And then also don't forget to include your vertex at the bottom. And just because I ran out of room, I just put V, meaning vertex, at that point. And then you graph these points. So the work is actually a lot less because we have this vertex form. You're going to do a lot of vertex form in Algebra 2. It's kind of nice. And I got these big things. They're new. So we're going to draw a coordinate plane. Hand draw yours. On X, let's just go... You know what? We don't need all quadrants. Let's see what quadrant you drew based on your X and your Y. Because our X values are all positive. Our Y values are all positive. I only drew quadrant 1. I mean, you can do them all if you want, okay? But remember, we are also comparing it to the parent function, so I guess I should probably put more out here. Because we're comparing y equals x squared. Okay, so I'm going to make mine larger, so every line on mine, okay, 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6, 1, 2, 3. So I made mine bigger, okay? And so we're just going to plot the points, 2, 4, so right 2, up 4, 1, 2, 3, 4. 6, 4. 2, 3, 4, 5. The cool thing when you have your mirror points, especially when you're on your graph paper, they should be right across from each other. If not, then you plot them wrong. So that's kind of something to look forward to help you out. So 3, 1 and 5, 1. And then also don't forget your vertex at 4, 0. Hey, whoops, that's not 4. There we go. And remember, these are parabolas, which means they are in U shapes. So there is the function y equals the quantity x take away 4 squared. Remember, you could have actually multiplied that out. You would have gotten x squared minus 8x plus 16. And then you would have to find the axis of symmetry. You would have to plug that in to find y. So you have your vertex. And then you would still go through this same process of finding matching x's, which I kind of like vertex form better, okay? So there's that graph. Remember when you compare it to the graph of y equals x squared, remember you're just graphing your perfect squares. So when x is 1, y is 1, but also when x is negative 1, y is 1, and always 0, 0. When x is 2 and negative 2, y is 4, which is the same point they have right there. Okay, so this is the quantity x take away 4 squared. This is your parent function. So if we compare it to it, what did it do? It shifted 1, 2, 3, shifted 4 to the right. Okay. So I ran out of room, so I'm just going to put it right here. Graph shifted 4 to the right. Right there. And that's your other part of your answer. That's the graph. That's your comparison. I like vertex form. Okay, next up. This graphing pad is new, the ones I just showed you. Instead of using my board, it's bigger. I got it at that one of those math conventions I was at. Kind of like it. It's kind of nice. It's nice. And actually, I'm going to clear my whole board so I have more room. I'm just going to rewrite my vertex form, y equals a times quantity x minus h squared plus, okay. Super easy to forget that square in there. So just always make sure you have a square. Okay, so that's our vertex form. So example 2. Remember, guys, you could pick any values of x you wanted. The book did pick values of 0, 2, 6, and 8. I don't care what you pick. Pick whatever you want. I always just do one in front, one in back, and then one in front of that one, and then one in back of that one, just because they're same distance and they're just the next values. It just makes it a little bit easier for my brain. But again, you can do whatever you want. Okay, so we're going to do example 2. Example 2 is graph, so we're just going to add the different pieces of the function in our vertex form. So now we have y equals the quantity x plus 5 squared minus 1. And of course, compare to y equals x squared. You don't need to recopy that. I just rewrote it. So now on this, the difference between example 1 and example 2 is they now have a k. That's all. If you are realizing you don't like vertex form, here's what you could do. You could square whatever binomial is there, get that answer, and then also, if you have a k, you're going to either have to add or subtract. If you have an a that's greater than 1, or anything other than 1, then you would distribute the whole function by that number. And then you get y equals ax squared plus bx plus c. Find axis symmetry, get that, plug it in, find y, then find your values of x and y. I like vertex form, but you don't have to use it. It's shorter. You might want to use it. Here we go. Okay, very first thing you have to identify your vertex. Vertex. It's kind of like saying math gods are like, hey, we're going to make this shorter for you. We're going to come up with this form called vertex form, which, by the way, always has a square of a binomial. Always. We're just going to shorten this down for those kids. Thank you. Here we go. So the vertex, remember, we're going to take the opposite of this, because remember, it's always x minus h. Well, if we're subtracting a negative, that's why it's plus. So just take the opposite if you don't want to remember what we're subtracting. So it's negative 5, because that's opposite of positive 5, and then negative 1. Okay. And if we just take a look, a is 1, so the graph is still opening up. So this is going to be a minimum point. This is going to be your lowest point on the parabola. Okay, let's find values of x. 1 in front of negative 5, which is negative 4. And 1 in back of it, negative 6. 1 in front of negative 4 is negative 3. 1 in back of negative 7, negative 6 is negative 7. I called it on myself. So those are your values of x that I would pick. Again, pick anything you want, but here's the thing. You've got to have this half of the parabola, and you got to have this half of the parabola. That's why I always pick mirror image. You can't just pick all the numbers over here, because you won't have a parabola. That's the whole point, is to have this u. Okay, here we go. X. So we have the quantity x plus 5 squared minus 1 in your double t-chart. Do not squish. Show all the work. One line per work in one line over here. Please don't squish. Okay, so we have negative 7, negative 3. I'm going negative 3. Doesn't really matter what you pick. Okay? Do the work in the parentheses first. Negative 3 plus 5 is 2. 2 squared is 4. I froze. This is no fun. Whoops. Okay, pausing. You have 2 videos to watch.